Welcome to the DIY Honda Garage channel. The DTC P1844 pertains to a malfunction detected in the continuously variable transmission (CVT) input shaft speed sensor circuit, specifically indicating a problem with the forward rotation range or performance. This diagnostic trouble code, DTC, is significant as it directly affects how the transmission control module, TCM, reads the rotational direction of the drive pulley. The CVT drive pulley speed sensor, which is responsible for this monitoring, is located externally on the end cover of the transmission. It employs a semiconductor that detects the position of the drive pulley and generates pulsing signals that communicate with the TCM. When the rotation of the drive pulley changes, the associated magnetic flux also varies, which gets converted into electrical signals. Inconsistencies between the driving conditions and the detected voltage levels of these signals lead the TCM to recognize a fault and store this code. The CVT drive pulley speed sensor is a crucial component of the transmission system that monitors the operational parameters of the continuously variable transmission. Situated on the end cover of the CVT, this sensor utilizes semiconductor technology to detect variations in the position of the drive pulley as it rotates. As the pulley turns, the sensor tracks changes in magnetic flux and translates these changes into pulsing electrical signals sent to the TCM. Specifically, this sensor helps determine the rotational direction of the drive pulley, which is vital for proper transmission operation. If the voltages generated from these pulsing signals do not align with expected values under driving conditions, the TCM interprets this mismatch as a fault, prompting the storage of DTC P1844. There are a couple of primary causes that may trigger DTC P1844. The first and most likely cause is a failure in the CVT drive pulley speed sensor itself, which may no longer function correctly due to wear, damage, or electrical faults. This sensor's inability to accurately detect the position of the drive pulley will lead to mismatched signals being sent to the TCM. The second possible cause is a malfunction in the internal circuit of the TCM, which may impair its ability to interpret incoming signals from the sensor properly. Given these two scenarios, thorough checks of both the speed sensor and the TCM are critical for precise fault diagnosis. When DTC P1844 is present, several symptoms may manifest, primarily affecting vehicle performance. One of the more observable symptoms is unusual transmission behavior, where drivers might experience erratic shifting, delays, or abrupt changes in transmission operation. This happens because the TCM cannot accurately determine how the transmission is functioning without proper input from the drive pulley speed sensor. Additionally, the shift position indicator may begin to blink, signaling to the driver that there is an underlying issue with the transmission system. Although the malfunction indicator light, MIL, does not illuminate with this DTC, the blinking indicator serves as an early warning system for potential transmission-related concerns. The first step in troubleshooting DTC P1844 involves starting the engine, which sets the stage for subsequent diagnostic tests. By initiating engine operation, you can confirm if the DTC persists upon monitoring. It is during this phase that any pending DTCs or faults in the transmission control system may become evident. You'll want to utilize an appropriate scan tool to communicate with the TCM, allowing you to view any stored or pending error codes that could provide further insight into ongoing issues. As a standard diagnostic practice, ensure that the engine is at a stable operating temperature to capture accurate data and responses from the vehicle systems. Next, it's essential to drive the vehicle in drive mode while maintaining a speed of 19 miles per hour, 30 kilometers per hour or more for a minimum of 5 seconds. This particular step is crucial as it simulates normal operating conditions under which the CVT would typically function. At this speed, the drive pulley speed sensor should be actively engaged in sending real-time data back to the TCM. Recording the output during this phase is pertinent because it assesses whether the sensor is accurately reporting the rotational direction of the drive pulley. Make sure to maintain a consistent speed to obtain relevant diagnostic readings. This driving test will help identify whether the issue lies with the speed sensor or the TCM, based on the data generated. Following the driving step, the next action is to slow down the vehicle and bring it to a complete stop. This part of the troubleshooting process serves multiple purposes. It allows you to assess how the vehicle's transmission responds under deceleration, and it provides a vital chance to monitor for any changes in the TCM's behavior or indications. Pay attention to the shift position indicator while performing this action. If there are no other issues impacting performance, the indicator should ideally not flash or display any alert warnings upon stopping. This observation is significant for diagnosing whether the DTC persists as part of the ongoing checks or has been resolved, further indicating the efficacy of the CVT's behavior and controls. In this step, you'll turn the vehicle to the off lock position after bringing it to a stop. Turning the ignition off allows the TCM to reset and can clear any temporary issues that may have been flagged during operation. This action is critical for resetting the system and reviewing any error statuses after cycling through the diagnostic process. If DTC P1844 reappears during subsequent tests, there is a strong likelihood that a persistent fault is affecting either the CVT drive pulley speed sensor or the TCM internally. After performing this procedure, ensure to wait a few moments before proceeding to the next diagnostic steps or repeating the driving pattern to gather more results pertaining to the issue. The final troubleshooting step in this diagnostic process is to repeat the driving pattern steps once again. By cycling through the established procedures for starting the engine, driving at the specified speed, stopping, and turning the vehicle off, one can gather additional data regarding the sensor's performance and the TCM's response. This repetition is significant because it can reveal whether the initial symptoms persist or if there has been an improvement. Special attention should be paid to how the shift position indicator reacts following these tests. If the error code reoccurs, it confirms that further investigation of either the CVT drive pulley speed sensor or the TCM is necessary. It's important to perform this repeat under traffic regulations and safe conditions for accurate results. After all diagnostics and potential repairs have been completed, it's crucial to carry out final verification checks. This involves examining the functionality of both the CVT drive pulley speed sensor and the TCM to ensure that they are operating correctly. Use a scan tool to clear any DTCs that were previously logged. This will allow you to reset the system and monitor for any reemergence of issues. Once the DTCs are erased, conduct a test drive to evaluate the overall performance of the transmission and verify that there are no lingering concerns. It's essential to confirm that the shift position indicator operates normally and does not exhibit any irregularities afterward, ensuring that all systems are functioning as intended. This verification phase is a critical step to guarantee the success of the diagnostic and repair process. Preventive maintenance plays an essential role in sustaining the health of the CVT system and mitigating issues associated with DTC P1844. Regular checks on the CVT drive pulley speed sensor can help in identifying early signs of wear or electrical malfunction before they escalate into more significant problems. Monitoring the transmission's function is also crucial. Any irregular shifts or indicators should prompt further investigation. It's recommended to follow routine service intervals and adhere to manufacturer guidelines regarding fluid changes and system checks to ensure optimal performance. This proactive approach can avoid prolonged downtime and expensive repairs tied to sensor failures or circuit issues, promoting longevity and reliability within the vehicle's drivetrain. In summary, DTC P1844 points to an issue within the CVT input shaft speed sensor circuit that affects forward rotation detection. By taking a thorough approach in fault diagnosis and addressing both the speed sensor and TCM, one can effectively resolve the issues signaled by this code. The troubleshooting steps clearly outline the proper procedures for verifying the performance and functionality of the transmission system. Attention to preventive maintenance practices will help reduce the likelihood of encountering similar DTCs in the future. Ultimately, understanding the role of these components and their interaction within the transmission system is critical in maintaining the vehicle's overall performance and reliability. Please like and subscribe to the channel. See you next time.